Good afternoon, friends. Today I want to explain about Lab 6. Wireshark Lab 6 is IP Internet Protocol. In this lab, we will investigate the IP protocol focusing on the IP datagram. We will do so by analyzing a trace of IP datagram sent and received by execution of the traceroute program. We will investigate the various fields in the IP datagram and study IP fragmentation in detail. So, first step is capturing packets from an execution of traceroute. So, this is the some introduction given about the traceroute and some protocols ICMP are given. So, in ping plotter we can see the HOP, count, IP and average min current, and there is a graph. This is a server which is running in this ping plotter. If you are not installed ping plotter for Windows, so this is a link for that Windows. You can easily install ping plotter. Ping plotter is a network monitor and troubleshooting solution that helps millions of internet citizens find the source of network problems and prove the culprit. So this is the IP address running through the network, and this is the name for this IP address, and these are the counts. And next, start up Wireshark and begin packet capture, and then press OK on the Wireshark packet option screen. So now go open Wireshark and capture. So you can see the network is running over these protocols ICMP, because of we added ping plotter for this. So these are the protocols are running now. Now we have to open IP traces which we are downloaded initially. So these are the IP traces. So now we will get these kind of protocols when we open IP tracer file from our laptop through Wireshark. Now we are completed our first phase of this lab. Next we are going to look at the captured trace. Already we opened this ICMP protocols in our Wireshark. So if we want to print protocol, just go to file and just print. Now you can print here, or you can print selected packets only. So you can select here range, how much. Now let's go to the questions what we have mentioned here. Select the first ICMP echo request message sent by your computer and expand the internet protocol part of the packet in the packet details window. Select first ICMP protocol and the IP address of this one is 192.168.1.102. Next question is, within the IP packet header, what is the value in the upper layer protocol field? Open Wireshark and select TMP. So the within the IP packet header, what is the value in the upper layer? So ICMP11 is the upper layer value of this protocol. And next question is, how many bytes are in the IP header? How many bytes are in the payload of the IP datagram? Explain how you determine the number of payload bytes. There are 20 bytes in the IP header, which leaves 64 bytes for the payload of the IP datagram, because we are sending a packet of length 84. And next question is, as this IP datagram been fragmented, explain how you determine whether or not the datagram has been fragmented. The fragment offset is 0, therefore the packet has not been fragmented. And so next question is, which field in the IP datagram always change from one datagram to the next within this series of ICMP messages sent by your computer? The header checksum and the identification changes from each datagram to the next. And next question is, now fifth question, which fields in IP datagram always change from one datagram to next datagram? This question is completed. Next question is, sixth question, which field stays constant? Which of the fields must stay constant? Which fields must change? Why? Fields that stay constant is version IP4 and the length of the header. See, length of the header here 4. Next, source IP address 9. Next, destination IP address. Upper layer, use upper layer protocol. This one. Always fields they stay constant. Fields that must stay constant is same as about the 4. The 5 has to stay constant. The fields must change there. Here the fields must change are the header checksum and identification. Identification and header checksum. And seventh question is, describe the pattern you see in the values in the identification field of the IP datagram. So you can see here the identification of this packet is 3008 and identification for next packet is 40316, and previously it was 8, now 9, and next for it will be 10. So it is in the increasing order. The pattern in the identification field is that field increases by one in each strand of echo requests. And the eighth question is, what is the value in the identification field and TTL field? Do these values remain unchanged for all the ICMP TTL exceeded replies sent to your computer by nearest fast HOP? What is the value in the identification field in the TTP field? Identification is 13011 and TTL is 4. Next question, do these values remain unchanged for all the ICMP TTL exceeded replies sent to your computer by the nearest? So the identification field changes from all of the replies because this field has to have a unique value. If they have the same value, then their replies must be fragments of the bigger packet, like this. The TTL field does not change because time to live to the first HOP router is always the same. Time to live also is changing sometimes. And next thing is fragmentation. Find the first ICMP echo request message that was sent by your computer after you changed the packet size in ping plotter to 2000. Has that message been fragmented across more than IP datagram? So this is the first ICMP echo request that was sent to your computer. Ping changed the packet size in ping plotter to be 2000. Fragment. Is that the message has been fragmented across more than one IP datagram. Next question was, print out the second fragment of the fragmented IP datagram. What information in the IP header indicates that this is not the first datagram fragment? Are there more fragments? How can you tell? The second fragment is obvious because it now has a fragment offset of 1480. There are no more fragments because it no longer has a flag set for more fragments. And 13th question is, what fields changes in the IP header between the first and second fragment? Now find the first ICMP echo request message that was sent by your computer after you changed the packet size. The fields that are changed is length, flag sets, and fragmentation offset, and next here checksum, header checksum. Now how many fragments were created from the original datagram? After switching to the after switching to the 3500 bytes, 3 fragments are created. What field changes in the IP header among the fragments? The fields that changes are the fragment offset is 0, to 2960 and checksum. The first two packets also have lengths of 568 and more fragments flag sheets, while the last fragment is shorter of 56 and does not have a flag sheet. So finally I am concluding Wireshark Lab 6 IP Internet Protocol. Thank you.